All right, now let's find the volume of two other solids, this time pyramids and cones. So our formula for the volume of a pyramid is 1/3 the base times the height. So pretty similar to what we saw with prisms and cylinders. But now since we have triangles meeting at this point up here, we have 1/3 the base times the height. Our base is down there, and our height is this measurement right here from the center all the way to the top. This is not the slant height, which is the height of one of those triangular sides. We talked about that when we did surface area. Slant height would be this right here. We're talking about our height from the middle of the base all the way to the top of the vertex that makes a right angle with the ground. So here we want to find the surface area of the pyramid. So here our base is an equilateral triangle with sides of 10 and our height is 12 inches. So the first thing we need to think about is, okay, what's our formula? 1/3 base times height. And we need to find the area of the base. So how do we do that? Well, it's a triangle. So we need to do something that we've done a bunch of different times. We would need to draw in our height and draw in our angles and figure out what the height of this triangle would be. And so here we would end up with 5√3 as the height of our triangle. Our base is 10, and so if we multiply this stuff together, we end up with 25 times the square root of 3 inches squared. That is our area of the base. We know our height is 12, so then we do 1/3 our base times our height, and we end up getting 100 times radical 3 inches cubed, which is approximately 173.21 inches cubed. All right, let's look at another pyramid. So here we've got a square base, where each side is 8 feet. And this time we're given the slant height, which is 16 feet. So I mentioned before that the height in our formula is not the slant height. We need to find the height. So how do we do that? Well, we first are going to find the area of the base. 8 times 8 is the square, but we don't know the height. So let's draw a triangle and use the Pythagorean theorem to figure out what it is. So notice here, this side of our triangle is 4 inches. That's because they're going halfway across the base, and we know each side of the base is 8. So we've got 4 inches here for one of the legs of the right triangle. 16 would be the hypotenuse of the triangle, and we're trying to find this other leg right here. So we're going to set up 4 squared plus h squared equals 16 squared. If we solve for h, we end up with h squared equals 240, and we have h is the square root of 240 inches. All right, so that is our height right there. And now we have our base and our height that we can plug into our formula. 1/3 times 64 times the square root of 240, which gives us approximately 330.49 inches to the third power. All right, cones. Cones are pretty much the same formula as we just had with pyramids. It's 1/3 the base times the height. Again, here our base is a circle, so we have that pi r squared in place of b, but it's really just the area of the base times the height, and we're taking 1/3 of that. And just like in the pyramid, our height is this distance from the middle of the circle all the way to the vertex. It's not the slant height here like it was for surface area. It's this height right here. All right, so let's find the volume of this cone. Well, we have the radius, it's 21. We have the height, it's 28. So we just plug them into our formula, and we get 4,416 pi centimeters cubed, which is approximately 13,000 centimeters cubed. All right, in our last example here, we are given the slant height of 50 and a diameter of 28, and we're going to find the volume of this cone. So first, our radius is half of the diameter, it's 14. And now we want to figure out what this height is. And so just like we did with the pyramid, we can use the Pythagorean theorem to do that. We have a leg that's 14, we have a hypotenuse that's 50. We want to figure out the other leg. Let's do the Pythagorean theorem and solve for h. We're going to take the square root of 2,304, and we get 48 meters for that height. So then to figure out the volume of this cone, we're just going to plug in what we know, 1/3 times pi times the radius squared times the height. Well, the radius is 14 and the height's 48. So we get this answer of 3,136 pi meters cubed. And there's our answer right there.